As a part of this faculty development program, first of all, let me convey our thanks and regards to Dr. DrSridharIyer. Sir, we, the Department of CSC, Sri Vishnu Engineering College for Women, Bhimavaram, from our bottom of our hearts, we convey our thanks to your valuable presence.
Sunil sir, just a minute. Just can we have the banner of Dr. DrSridharIyer sir? That will be better now. We have the banner now that was created.
Kiran sir. Kiran sir.
Sir, please proceed, sir. Yes, please.
Yes. So good afternoon, sir. Dr. DrSridharIyer. With the Department of CSC, Sri Vishnu Engineering College for Women, Bhimavaram. We thank you, sir, for joining with us to share your valuable knowledge. Before entering into the session, let me take a few minutes to introduce you, sir. It is my great honor to introduce Dr. DrSridharIyer. Dr. DrSridharIyer received the BE degree in Electronics and Telecommunication Engineering from Mumbai University, India in 2005. He received MS degree in Electrical
Sunil sir, please unmute yourself and proceed, sir.
Thank you, sir. Thank you, sir. Sir, sorry for the disturbance. Dr. DrSridharIyer received a BA degree in Electronics and Telecommunications Engineering from Mumbai University, India in 2005. He received MS degree in Electrical Engineering from New Mexico State University, USA in 2008. And he received a PhD degree from Delhi University, India in 2017. He received the Young Scientist Award from the Department of Science and Technology, SERB Government of India in 2013, and the Young Researcher Award from Institute of Scholars in 2021. He is also the recipient of the Protsahan Award from IEEE Bangalore as a recognition to his contribution towards papers published, tutorials offered in recognized conferences, journals during January 2020 to September 2021. He serves as a member of the editorial board of the Sci-Hal Journal of Computer Science, Journal of Optical and Wireless Networks, and Information System and the Smart City Journal. Currently, he serves as an associate professor in the Department of ECE, KLE Technical University, Belgavi, Karnataka, India. His research focuses includes semantic communications and spectrum enhancement techniques for 6G wireless networks and efficient design and resource optimizations of the flexi-grid optical networks enabled. He has published over 100 reviewed articles. And sir, really, we are very glad to have such an eminent personality as a resource person for this faculty development program, sir. Sir, now I request you to share your valuable insights in intelligent wireless networks, optrons, and challenges.
Thank you, sir, for that introduction. Let me share my screen. Sir, I think it will be possible. No, let me just check. Okay. I hope my screen is visible, sir.
Yes, sir. Your screen is visible.
Okay. So I'll do one thing before I start off. I'll just switch off my video to save on the bandwidth. And later when we're taking questions, I think I'll switch it on again. I'll reshare my screen again, sir. Okay. I hope my screen is on, sir.
Yeah, it is visible, sir.
Okay, sir. Okay, so I'll go ahead. So again, thank you very much for the invitation, Kiran sir, and thank you very much for the kind introduction, Sunil sir. Good afternoon to all the participants. The topic that I'm going to talk about is intelligent wireless networks, opportunities and challenges. To many participants.
Just a minute.
Yes, sir.
Please proceed, sir. We have one
Okay,
minute.
thank you. To many participants, it may look like it is more of a communication and networks topic, but if you look at the first if you look at the first word, it says intelligent, and that means that we're going to talk a lot about artificial intelligence and machine learning. So this is one of the use cases or applications of AI and machine learning, which can be used in wireless networks. Similarly, you can also use AI and machine learning in optical networks, satellite communication, so on and so forth. So it is not something that is outside of the FDP. It is in line with what the FDP is basically standing for. Right? So let me go ahead. We basically don't need any motivation for AI and machine learning, but just to create a background, where we were almost a decade back and where we are now. Back then, smartphones were very new, around 2010, and they were very intriguing, but now they have become very old and absolutely everybody has those. And in 2020 and 21 22, we are having more of smart gadgets, and COVID really has spurred this whole idea of having smart gadgets and smartphones and many other things. So those smartphones are not any more new for us. They are better devices, better gadgets which have come, but this is not where the human society is willing to stop. Our applications are growing, and they want to be more intelligent and have less human intervention. So what we are looking for in the next decade or so is things like AR, VR, and also a mix of those known as mixed reality, digital twins, holographic communications, and so on and so forth. So that is what that picture really shows you. There's no comparison between humans and machines, but of course machines will exceed the human limitations, but machines are always going to be governed by how the humans are going to use them. So it is up to us as a society to build and deploy such machines which are doing the right things, and are doing doing such kind of activities which will really make our society much better in all sense. So a quick retrospect or history of wireless communication, just to give a completeness. So like any communication, wireless is also built on the information theory by Shannon in 1948. We started off with 1G wireless communication, which is basically an analog communication, and it was basically used for voice communication. And then in 1990s, we went towards the digital communication, and we started having.
Sir, Sridhar sir, you are muted, sir. Please unmute yourself. Thank you. Sridhar sir, you are muted, sir. Please unmute yourself once.
Okay, I'm back again. I think someone would have muted me, I think.
Yes.
Okay.
Sorry for the trouble, sir. Thank you.
No problem. So is my screen visible again?
Yes, sir. Your
Yes, sir.
screen is visible, please.
Okay. So I think I was at the 3G wireless communication. Compared to the 2G communication, which was digital and it gave us applications such as SMS, encrypted services, 3G was more enabling the society towards data services like internet access, video calls, mobile television, and so on and so forth. And this was basically based on the CDMA technology. But this was not enough for our society, and we wanted more bandwidth or data rate. And therefore, the 4G or long-term evolution (LTE) came along, based basically on OFDM technology with multiple input, multiple output antenna technology. And predominantly, India today is based on the 4G LTE. Very lately, the 5G has been introduced, and probably in a year or so, we'll have more of 5G. But predominantly, we are 4G based, and we are able to achieve very high speed mobile transmission. So basically, this entire generation of wireless communication has helped reshape our society. And the pandemic, COVID, really spurred this entire thing where, since we are all education based, we know what was the scenario where the entire online education was based on, predominantly the 3G and 4G wireless communication. Uh, so let's see a quick overview of what this 5G technology is. So when compared to previous generations, specifically the 4G technology, 5G is basically looking at interconnecting everything rather than Internet of Things. In 4G, we are talking more of IoT, where we only want to connect things or devices. Whereas in 5G, the aim is to interconnect everything. That means wherever you are on this earth, you will always be connected. So a very layman example will be if I'm on the basement of my building, there won't be any issues such as I'm not getting the network, which happens in 4G. 5G will keep you connected probably through optical fiber cables in the basement. Probably when you are traveling through flight, you're connected through satellite. So you're always going to be connected. That is the aim of 5G. So the data rate that you're getting is also very, very high. So 5G is not something new. The work basically started somewhere back in 2012, where 4G was just getting deployed. The paper work kind of finished in 2018, and now we know that these deployments are ongoing. Countries such as Finland have already had 5G for almost over a year, and countries such as ours is going to have 5G very soon. So what are the indicators for 5G? Well, the most important is from a customer viewpoint, we'll get what is known as enhanced mobile.
Sure.
No.
So the challenging indicator for 5G basically would be from a customer viewpoint is that we will get very enhanced mobile broadband that is very high data rate. For a very populated country like ours, we will probably have just many users packed into a very small area, and all of them will be connected. So almost a million connections per square kilometer. Basically, the wireless technology will be based on similar technologies such as 4G. For example, you'll have the MIMO technology, advanced modulation techniques, high frequency, software-defined networking, so on and so forth. So we have done some amount of work on the 5G, and it appears in a journal from Taylor and Francis. And there we could see that what are the major key technologies on which 5G would be dependent upon. But even though 5G is not deployed globally yet, it is there only in few countries. There are already issues which have started. For example, you always deploy these generations from a customer viewpoint, and the customers are always interested in only having higher data rate. So the mobile broadband aspect of 5G has already taken more significance compared to other parameters such as low latency and machine type communication, human to machine communication, so on and so forth. So there is already an imbalance in the parameters which 5G is promising. There are already difficulties even before 5G has become, a very prominent kind of network globally. If we really want to have the Internet of Everything as 5G is aiming to do, there will be a lot of issues, specifically from the industry viewpoint. We really do not know what are the future actual demands. Right now, we only know that
See, all the participants are requested to mute themselves. Sir, please proceed, sir. Sorry for the trouble, sir.
no problem, no problem. So with the Internet of Everything, we really don't know what.
Sir, Sridhar sir, please unmute yourself, sir. Someone.
Sir, just a minute. Sunil, sir, if you can remove the participants if they are doing that like this.
Yes, sir.
Because we should not disturb the resource person's flow.
Yes, sir. I will do it.
Okay, so I think I'm audible now again, sir. And
yes, sir, you're audible, sir. Please.
Okay. Okay.
Yes, sir.
So we really don't know what will be the demands in the future, and we only know from all domains, especially AI and machine learning, that this data is just increasing exponentially, but we really don't know the actual demands. We also don't know how the industry will behave in response to these increase of the demand. So there are a lot of issues if we are talking about Internet of Everything. To some extent, it has been possible for us to capture the Internet of Things, but Internet of Everything is just it's a perspective we really don't know if we'll be able to satisfy or not. So 5G already has some issues, as I was saying, before its deployment. So this is how we can view the issues with 5G. So if you compare this with previous generations, well, voice communication was basically defined in 1G, but we know that it was 2G, which was used a lot for voice mobile communication. Similarly, the mobile internet was actually defined in 3G, but its actual implementation happened in 4G. And we have used this extensively during the COVID period, especially for online education. So what has been observed till now is that the previous generation, any previous generation would specify its aim, and then it will be the next or the successive generation which will be able to implement that. So going with the same experience, it is quite likely that whatever has been planned or aimed by 5G will have to be done by its successive technology, which many people are calling as 6G. But then there is also a group in the research community who call it intelligent wireless communication. And I will come to the perspective why it is known as intelligent wireless communication. So as I was saying, if you look at the trends in the wireless generation, I think all the participants would agree that this is what has happened. Going from 2G to 3G took us almost a decade and a half. But then going from 3G to 4G was not that much. It was very quick. And the reason is our applications are, advancing and increasing day by day. And going from 4G to 5G hardly has taken us about 5 to 6 years. Of course, implementation takes time, but the entire idea and perspective on paper has been very quick. So going from 5G to 6G already, since I am into this research, I have already seen that within a span of 2 to 3 years, things have changed a lot, and a lot of new things have emerged. For example, digital twin, which was basically just on paper and people were just putting the idea. Now, even in India, we are having researchers who are working on digital twin. So a lot of this research has picked up a lot. So research on 6G, I won't say it has been on schedule. It has been more than on schedule. And very quickly, this research, at least on paper, will be finished. And then we could look at the deployment. So let's see, why are we really talking about, moving on from 5G towards 6G, even though 5G is not yet deployed. So we're looking really at a very large coverage of system. That is, we want to cover the entire globe, that is Internet of Everything. So Samsung came up with a very good diagram, which I'm showing here. And it really sums up why we want to move from 5G to 6G very quickly. So if you look at the user experience data rate, it's somewhere around 0.1 Gbps in 5G and this will increase to 1. That is a 10-time increase in 6G. So that for a customer is really good news, because I'm looking at very high data rate. So if I'm, let's say, into online gaming, or online stock market and brokerage and those kind of things, then this is really good news, because I can access the data and transmit, receive data very quickly. Of course, there are challenges because I cannot do this manually. It has to be done automatically, and that is where AI and machine learning comes into the picture. From a communication perspective or saving power perspective, if you see, the energy efficiency and spectral efficiency would increase 2 times. For a populated country like India, if you see, the connection density will improve from 10 raised to 6 to about 10 raised to 7 devices per square kilometer. That is, I can have more population in a small area connected when compared to 5G. This will be an increase in 6G. But really, we do not know what is the description of 6G. There have been some perspectives which I will show in the forthcoming slides, but we really do not clearly know what this 6G is all about. So as I was saying, this research is not new. It started long back. So the first versions of this 6G came up in 2017 in the European Union. In 2016, previous to that, it was the JUMP project in USA, which was actually granted by FCC. So this was an official kind of research on 6G. The thing to note there is the frequency range. It's very, very high. We're looking at about 1 terahertz. That's a very, very high frequency there. So through this high frequencies, how we can achieve very high data rate, right? So what is the need for 6G? I think I've already covered this, but I'm showing this in terms of the graph. And these two graphs show the total global volume, traffic volume, that is globally how much data we are accessing. And the graph at the bottom in blue histograms is showing what is the traffic volume per subscription, that is per user. So let's just take users, that is ourselves, and we can see that in 2022 we will be consuming somewhere around 12 gigabit per month. That also I believe is quite less, because I think every month if we check what is our data consumption on our mobile phone, it will be much higher than 12 GB per month, but that's an average. And you can see in around 2030 this would have increased to about 250 GB per month. So
slide is not, sir. Sorry for interruption, sir. Slide is not moving.
Okay. I think now I'm in need for 6G. Is that correct?
No, it is in wireless communication itself, sir. I don't know for everyone. In my mobile, in my video, wireless communication itself.
Okay.
This speed is not changed. Not
on slide number 3.
Okay.
Same thing for everyone.
Yes, sir. It starts with wireless communication and 1980s, 1990s.
Yeah. The same thing.
Yes.
Okay, I've reshared again. I hope now it's visible.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So I hope now you're able to see the two graphs.
Yes, sir.
Okay, fine. Okay. Thank you for letting me know. So this is what I was saying. We have the graphs, and the blue one is what shows the increase in the data consumption by each user. And so the entire point here is, if we have the same infrastructure that we have today in 2022, it will not be enough to cater to the needs of what is required in 2030, because the data consumption, as you can see, would have increased from about 12 GB per month to about.
I have sent like this.
I sent mail to that Kiran Shri.
So the data would have increased from about 12 GB to about 250 GB, and so we need newer infrastructure, and we need newer advancements. And infrastructure is more on the networking side, but the advancements in technology is more on the AI and machine learning, and that is something that I will cover in the forthcoming slide. So the whole idea is that we want to connect everything on this planet. This is a major difference. We don't want to connect things. It is not IoT. We want to connect everything. That is, wherever we are in the planet, we need to be connected. So this is one of the proposed architecture of 6G, and I was saying that if we even have
Sir, please continue.
Sridhar sir, you're muted again. Please unmute yourself, sir.
okay, I think someone keeps unmuting me. I mean, muting me, sir.
I will change the privilege, sir. Sorry for this.
Yeah. Because every time I come to change or unmute myself, the slides don't change.
Yes, I understood, sir. I'm sorry for this trouble. Actually,
No problem. So I've unshared and I will reshare again. Okay, so I've reshared my screen again. I hope it's visible.
Yes, sir. It is.
Yes, sir.
Okay. So we are looking at the communication, which is more of integrated communication. This is a new term which has come about in the research community, and we are not going to look at communication standalone or independent communication like wireless communication separate, optical communication separate, or satellite communication separately, but we are looking at an integrated. So we have one communication which involves satellite as well as fiber as well as wireless and so on and so forth. So one might wonder why that is required. So if we take one person on this planet and just assume that this person is walking on the ground right now, for him to be connected, the antennas are required. Let's say an hour later, this same person is taking a flight and going from place A to place B. He needs to be connected, and that is where satellite comes into the picture. And let's say, few hours later, this guy is on the ship and, he's taking a ship from, point A to point B. He needs to be connected there. Therefore, underwater communication through possibly fiber communication would come into the picture. So the point is, wherever you are, you will be connected. So we're looking at a scenario like that. And of course, if you think from an AI perspective, we cannot do these connections manually. You cannot have a person sitting at some point and changing some knob to connect this person underwater or on the flight and so on, so forth. This has to be done automatically. So we need AI techniques, to do this entire process automatically. Not only just do this automatically, but do it at a very fast rate, because the user always wants to be connected, right? That is what we expect as a customer, always to be connected, right? So that is the whole idea. So what we are looking at in the next generation of wireless is what is known as a cell-free communication. There are no cells. So if you have taught a course on wireless communication, or if you have taken a course on wireless communication, the very first thing that you learn or you teach is, because of the curvature of the earth, there is a cell structure in wireless communication which is hexagonal in nature. But that is not applicable in the 6G. We just do not have any cells. So there's no concept on 6G of roaming or being local and so on and so forth. So that concept will go. Wherever you are, you'll just be connected, right? But this has its own challenges, which can be solved by artificial intelligence and machine learning. So I will come to those aspects and how we can actually solve these issues, right? So this is one of the proposed architecture of 6G. It looks complicated, but the whole idea here is to show that wherever you are in the planet, right, on the planet, underwater, or if you are there in the smart city, smart home, health monitoring, wherever you are, you will always be connected, and you will always have this network connection, which is not possible these days. Let's say at a basement or if you go to a remote place like a desert or near beaches, you'll not be connected, right? So we have those challenges right now, but 6G will remove those, right? So as I was saying, in the previous generation, so I've taken an example of 5G here. In the previous generations, we had these concepts of cells, where we are talking about macro cell, pico cell, or femto cell. But there are cells, right? Whether you are in a house, residential area, office environment, so on and so forth. But that concept goes away in 6G. So you just do not have any cells, right? You're just free as a customer user. You're just free to move about. So you can go from one network to another. So if you just visualize the map of India, and you are, let's say, in Andhra Pradesh right now, and you move towards Maharashtra, there's no concept of roaming there. You'll just be connected, right? But right now there is a concept of you being on the roaming and having those kind of issues, right? That will not be there. So this entire network will be automatically selected, right? And this is where AI comes into the picture. So there will be no concept of things like handover or handoff. There will not be such issues, and the quality of service for the user and the customer will be very, very high. And that is why we are looking at these kind of network architecture, but with challenges of AI and machine learning, right? So what is the vision? I'll quickly browse through these because these have nothing to do with the AI part, and I want to do more of the artificial intelligence part. The whole vision of 6G is to make our society intelligent. And whenever the term intelligence is used, you are looking at AI and machine learning. We need to tackle the challenge of coverage, the capacity. You need to cover the entire planet, or most of it. The capacity or the data rate has to be very high, and the user is always on the move. He's always going to be moving, either walking in the car, which is known as vehicular networks, or on a flight. So he's always moving. So with all this, I need to provide coverage and capacity. So in regard to the data rate, we can go to higher frequencies, and can provide much you know higher bandwidth. And once you have a higher bandwidth, you are able to provide much better data rate. But with higher bandwidth, you also have the challenge that some users may not use those bandwidth properly. So there, this bandwidth allocation and the use of these bandwidth needs to be done properly, and that's again where AI comes into the picture. So this diagram here really shows the concept of Internet of Everything, where you can see that you may be on a road, and through a traffic light you get the Wi-Fi. You could be in a forest and you get the Wi-Fi or connectivity through satellite, and this satellite is then connected to a base station on ground, known as terrestrial communication. You could also be in the ocean or desert, and through satellites you will get this coverage, right? So this is the whole idea of 6G or the intelligent wireless communication. So there are many requirements of 6G. One is, how do you share this very large frequency that we are getting? And this is where AI comes into the picture. So my research group basically focuses on how to use this frequency and how to share this frequency efficiently. There are also other issues such as cyberspace security, because you're always going to be virtually connected. So whenever we are talking about the cyberspace security, now recently we need to talk about edge computing, because with this the computation increases. So you cannot really depend on a remote server, which does cloud computing for yourself, because it will do the computation at a remote place and keep it, but then you need to access all that data. And since we are talking about low latency, you need the data very close to yourself. So the user equipment, let's say the mobile or the tablet which we are carrying, can become one of the servers, right? That's the whole concept of edge computing. So with edge computing, then you get much better data rate. Your security also increases, so that aspect needs to be covered. Merging of the computation and communication, this I've already covered, where you need to have different communications integrated with each other. There will be a lot of data. Big data will be one of the issues. Therefore, you can use a ledger technology like blockchain to have much better security, provide much better efficiency in terms of the spectrum or the bandwidth. So a lot of work is going on in edge computing these days. Of course, cloud computing will remain, because ultimately that server also becomes a user equipment. So that will remain, but edge computing has gained more attention. There's also the concept of swarm intelligence, where we take all these devices together, or people together, and then in a group we make them intelligent, right? It's like a classroom where we are teaching the same thing to a group of students, and we make all of them, or we try to make all of them intelligent on the same level, right? So that's the whole idea of swarm intelligence, which is different to artificial intelligence, because in artificial intelligence you're taking component by component and making them intelligent, right? There's a lot of work which is going on swarm intelligence as well. So few quick applications of 6G. Well, in 5G, AR and VR are the most important applications, but in 6G, it'll be more of holographic communication, or digital twin, as they say, because the advancements in computations will be much higher, as this graph is showing. So with those capabilities, we can have use cases such as Internet of Bots, brain computer interactions, the BCIs done wirelessly, and many other use cases. So here I'm just showing you a few of the applications. So this is from one of the white papers from Samsung. It was published in 2020. So it really shows what is this mixed reality, what is this 3D hologram, and what is the digital replica, digital twin, where we want to really close the gap between the real world as well as the virtual world. And today, I think sitting here, all of us agree that our society is moving towards these kind of applications. So already these kind of gaming technologies have already come in India. So if you go to all these malls, you will see that these kind of games are already there and kids are enjoying them. So very soon, I think this will be covered in our social life. So the next part is where I start talking about the artificial intelligence, and this will be a little quicker because here I want to just give the gaps which are there. There are many gaps, and which can be covered. If you want to start your PhD right now, or if you are into PhD and where you can go, or if you are a research guide and where you can have your students start working on. So this is all state of the art, and you can really, if you really work on this, you'll get really quality publications out of it. So the trend basically is to expand the coverage. We want to do that. We want to increase the capacity, and we also need to add many capabilities which will come through AI. We need to have new spectrum frequency, because the old existing spectrum is not enough. And we also need to have an integration of the communication, having different networks working together. So one of the best techniques is to integrate the terrestrial, that is, ground-based communication with satellite mobile communication, because the communication through satellite is known to be cheap, and also it covers a lot of ground. But there are some issues with satellite, and these are the ones that exist till now. One is that of Doppler shift. The other is of Doppler variation. These need to be covered. Also transmission delay, because we are talking about terrestrial or ground-based communication with satellite communication. So it's going to take a while for the signal to reach the satellite and come down. So that kind of latency can we tolerate. So that we need to check on. Also, we need to check what would be the delay between the two or multiple satellites up there, right? So that kind of delay also needs to be monitored. The next is what is known as the RISs, or the RISs, reconfigurable intelligent surfaces. So these are really new kind of aspects, and a lot of research is going on this. It's basically a hardware technology, and you can artificially, using AI machine learning, reconfigure the environment of the signals or the electromagnetic waves. So the diagram shows you that you have this reconfigurable intelligent surface which has these blue spaces, and you can now have the signal touch upon them and then go wherever you want them to go. So you can have a base station which is shown as an antenna, and this base station signal hits this RIS, and then whether you want it to go to a car or to a UAV or a mobile device, you decide, and this signal just goes there, right? Of course, this is easier said than done, but a lot of research is going on this intelligent surfaces. So a lot of AI is required there. Right? So this really has been shown to enhance the performance of the transmitted signals, and you can control the signals the way you want. Of course, this controlling has to be done through a lot of algorithms. The next, of course, is going to be the one that we always use, which is the MIMO technology. So you'll have many antennas put together, and all of these antennas will just provide you with a lot of capabilities and the capacity increase, right? So a lot of work is done by Ericsson in the massive MIMO research domain. So what we are basically doing is just increasing the space. That is, each antenna is a space. So this is a spatial multiplexing. So the more the antenna, the more is going to be the capabilities. And of course, the OFDM technology will remain if you are from a communication background. The next is in terms of spectrum, and this is where my research group works a lot. So what we are looking at is going from the electronic spectrum towards the photonic spectrum, right? So we're looking at this red color gap here, moving from what is known as a millimeter wave, which is somewhere around 300 gigahertz, going towards the terahertz, which is around 3 to 10 terahertz. So very high frequency there, right? So what is the whole point of going from low frequency to high frequency? The whole idea is that we want to go, we want to give higher data rate to the users, right? So you can look at terahertz in two formats. One is known as a solid state terahertz, which is based on any frequency mixing. So you take a low frequency, high frequency, mix them, and then you get a very high frequency. The other is a spatial direct communication, where it follows the basic modulation technique. You take a low frequency signal, and then that is your baseband signal. Take a high frequency carrier, mix them, superimpose them, and you get a modulated signal and you transmit them, right? But the problem is that we do not have modulators which work on these kind of frequencies yet, but a lot of research is going on, right? So we had a recent article in IT Journal of Research, where we looked at the performance of a 6G network, where we could allot these kind of frequencies and design a spectrum announcement technique. So you can have a look at that. So there are a lot of challenges. The main challenge will be in terms of AI, which algorithm to use. So I will quickly, very soon, come to those kind of algorithms which we can use. It's a tough ask to do these kind of spectrum allocations when it comes to hardware. And this is where academic research is limited because we are constrained by the hardware, unless, of course, you have the industry connect there. You can look at cognitive radio. There are a lot of studies which have looked at these issues, where there's going to be a contention between many systems to access the spectrum, and then you can have many spectrum sensing and management techniques. There's also something which is known as symbiotic radio, which gives you one more layer of access to the spectrum. So the second layer of subsystems will ask the system on top whether the spectrum is available or not, and then go ahead with accessing that spectrum. So a lot of work on symbiotic radio is also going on. Samsung has already shown that this kind of very high frequency will be used, but you need to use what is known as an AI engine. So if you talk in terms of the TCP/IP layer, for example, somewhere between the physical layer and the data link layer, you need to have this AI engine, which will control how the data is, how the spectrum is being accessed, how the contention is being resolved, and then which users will get the spectrum, which users won't get the spectrum. So AI will come into that picture, and it has been shown now by many studies that you can avoid to a large extent these collisions through the use of proper AI algorithms. So next is this is where I come into with AI. So AI will provide a lot of advantages, but it will have a lot of challenges as well. The main one, I think everyone will agree, is the hardware constraints. We are always limited by the hardware in edge AI. Also, in many of the domains, especially in the communication and networking, we are constrained by the data as well, because we don't have the real-time data. Possibly the medical people using AI would have access to real-time data through hospitals maybe, but in networks and communication, we are constrained by the data. So we need to create our own data. The other is a challenge would be in terms of edge computing. It looks simple, but it's very difficult to implement. So in terms of the AI, of course, you could use any kind of supervised or unsupervised learning, but then it is not fixed which learning would be better. It depends on application to application. And as I was saying, the data set is not available. So we need to create our own to train. And then, once you train more, then it becomes better. So basically, if I take the use case of communication and networking, you would see a lot of articles use the method of transfer learning so that you don't have to keep retraining the data again and again. Much of it is already trained in some other kind of application. And then that idea and knowledge is taken into, the existing problem, and you can save time and computation in retraining the data. The other is deep learning, and my group works a lot on the deep learning issues because we use a lot of classification. In some of our articles, we have also done some regression, but mostly we do classification. So what we have really found with deep learning is it is highly related to the model training. I think this is the case with most of the domains, but basically it is true for the networking domain. So now we have started to venture a little bit on the reinforcement learning, such as Q learning or having a Q table. But then the problem which we are facing now is with the data that increases, the Q table also increases, and that creates a big problem for us because data is exponential, right? So so some people have suggested, some articles have suggested that you can look at deep reinforcement learning. And this is currently what we are looking at, whether deep reinforcement learning is a good option or not. So we've tried deep learning, we've tried reinforcement learning. Right now, my group is looking at the deep reinforcement learning. So in network, basically your AI looks something like this, where on the left-hand side, we have the network as it is, existing network which is working, basically a TCP/IP kind of protocol, right? You have the physical infrastructure, the virtual resource, the management, so on and so forth. The new aspect is on the right-hand side, where you have the management done through AI, right? So all of this data is fed back to this orchestrator on the right-hand side. And based on that, these decisions are made.
Components కొద్దిగా పైకి పండించి ఇది కొద్దిగా లైన్ పైకి దాని తర్వాత కానీ ఓకేనా.
So based on this, the data, the corrections will be made and the error will fed back and so on and so forth. So AI does this for us. So articles which I've mentioned, the article which I've mentioned at the bottom has used this kind of an architecture and has shown really good result. Then you can also use machine learning based resource allocation. Here in networking, resource would mean spectrum, frequency, as well as power or energy. So we can use a lot of machine learning based techniques to allocate the resource and save a lot on the power. But how to do this properly in a wireless network? That is one of the questions which we are trying to answer. So we had a recent article in January 22, where we have tried to see what could be the best architecture and algorithm which will be used to allocate these resources properly, right? So we tried to use a greedy algorithm and a game theory, and we've seen how these two would work. But there are a lot of issues which we faced, and so I'm not going in deep into those issues, but what we found is the computation time of those algorithms increased as the environment became more complex, which I think happens with most of the AI applications, right? Also, we wanted to make these algorithms adaptive so that when the environment is changing, the algorithm also changes. That's the whole aspect of AI, right? And to some extent, we were successful. So right now we are, as I said, we are trying to implement reinforcement learning. So we had an article recently which is under review, where we have tried to use deep learning for energy, spectrum, and signal to noise ratio. So a lot of aspects are included here. The main takeaway from the study was that these algorithms again became very, very complex. They became non-polynomial hard, NP hard. And so we had to resort to some kind of heuristic to get the solutions. But of course, with heuristics, you'll not get the accurate solution. So that's a trade-off which we saw. There's also different machine learning based radio access technologies, 6G communication. So this is something that I'll just leave here because my group is also venturing into this. You could use the spatial multiplexing MIMO. So there are some aspects which are communication related here. But the whole idea here, what we are trying to do as of now is how to intelligently schedule, the access to resources by any user, right? And this has to be done automatically. So there are a lot of resources available, a lot of power, a lot of spectrum is there. How can I do this intelligently so that the network is able to save on these resources? So that is what we are trying to do here. So there are many challenges. You have the radio challenge, how to allocate the resource. If you're from the antenna background, there's a beamforming challenge, how to have the signal go right from the antenna towards the user. That's a basic challenge which many people are looking at. My group doesn't look at the antenna part. We are more focused on the spectrum issues. The other aspect is basically the 3D architecture, that is the integration of different communication together, and this has its own issue. So one part of my group is working on this protocol interoperability between these communication aspects, and also how AI will come into these aspects. So this is something very interesting we are looking at. So I'll quickly go through some of the use cases. These are something for the beginning scholars or for supervisors who are trying to look for problems which need to be solved. So one of the use case and application of intelligent wireless communication is the optical wireless communication, OWC. So the existing lights and bulbs which we have at home, they could become hubs, Wi-Fi routers, and that is the whole idea of optical wireless communication. Right? So there are a lot of issues here which one can solve. There are a lot of papers which are existing, which one can look at and see what are the challenges which exist. So this is one of the use case. The other is quantum communication, which is becoming very popular. There are a lot of studies trying to even have the computers as quantum computers. So quantum communication basically deals with the quantum qubits, and it is able to improve the data rate. There are different branches of quantum communication. The QKD, quantum key distribution, is one of the most popular. So anybody who's beginning research or looking for problems can look at quantum communication. There's another one which is WIET, which is wireless information and energy transfer. This is something which one of my group is working on. So we have an article as a preprint on archive. So you can have a look at it, where we have surveyed what are the WIET and related applications in 6G, specifically for Internet of Nanothings. So basically the idea is to increase the lifetime of the battery, and how can this be done, or how can you work without the batteries. So you can have a look at that paper. There are also other research opportunities which you can have. One is in terms of multiplexing. The other is in terms of how to save the energy. If you want to work on the economics part, you can look at the CAPEX or OPEX, how to improve the expenditure of the network. There's also something which is known as semantic communications, which I've recently started working on. One of my groups is working on that, where instead of just transmitting the data as it is, we transfer, or we try to understand the meaning or the context of the data. So through this, we are able to save a lot of bandwidth and also energy. So we had a recent survey article on semantic communications for intelligent wireless networks. It is up on archive and you can have a look at it. So overall, for these next generation wireless networks, the whole idea is to complete the process by 2030. That is what ITU has mentioned. And a lot of serious work on various applications and use cases are going on. So I think I've already concluded. So this is a very hot research area. Whatever you pick from this area is just state of the art, and there's a big chance for anybody to do very good work, state of the art work, and get a lot of quality publications. So there are a lot of problems which require solutions. So anybody looking for such kind of problems, scholar or supervisor, can really venture into this. So this is all from my side. If there are any queries, discussions, I'll be happy to take them.
Yes, sir. Very interesting session, sir.
Thank you.
Dear participants, if at all you have any queries, please you can unmute yourself and you can ask the questions.
Good afternoon, Dr. Sridhar, sir.
Good afternoon.
Yeah, this is Dr. Sudhir from VIT University. Hello, is it audible, sir?
Yes, sir. Yes, sir. You're audible.
Yeah, sir. What is the take of what is the take on privacy on this particular 6G issue, sir? Do you have any idea how privacy is playing a major role in 6G?
Yeah. To start off, my group doesn't work on the privacy and security, but as we have learned from various applications, since you're trying to connect many users in a very small radius.
That is what I'm interested, because when you are talking about edge computing and all, so there's a big challenge for this privacy and security, as we need to pose independent frequencies at different locations, right?
Correct. That's the whole idea.
Yeah.
So if you're able to use a quality AI algorithm to allocate the spectrum, or as you said, independent
actually, my scholar is working on edge computing with deep reinforcement learning. So that's what. So we are also looking for this kind of a research and all. Okay.
Yeah. So these are actually connected issues. Once, in my opinion, if you are able to have a proper spectrum or frequency allocation through a good AI or machine learning algorithm, then the subsequent privacy security issue becomes a lot easier. But then in real time, it is always going to be a challenge.
Yes. So we have our cybersecurity excellence center of excellence here in VIT University.
Yeah.
So we'll definitely in touch with you, and please share your details, sir. I've sent you a LinkedIn request. Please accept.
Sure. I'll do that. Thank you.
Thank you, sir. Thank you very much.
Thank you very much.
Thank you, sir.
Good afternoon, sir. Good
afternoon.
Sir, you mentioned something about interdisciplinary research in this particular domain. So how being from other like mechanical, like mechatronics, like EC graduate, will pick up some good research focus areas, and if you give me some ideas or some insights into that, it will be really helpful. Thank you.
Okay. So that's a very common question, and thank you for asking. So just to give you a brief idea, so I recently had attended one of the FDP myself, and it was on deep learning for crack detection in construction. So I think it's quite interesting to see how we could use deep learning from probably a computer science background to detect cracks for construction in civil engineering. So that is what I meant by interdisciplinary. Since you mentioned mechanical engineering, we are going to be looking at when you're providing, let's say if I just pick privacy and security, as Sir was mentioning before, you're looking at the drone technology or the UAVs, right? So allotting or allocating spectrum to them and also moving them around is one aspect which comes from the communication background, but to design them and have them prepared in real time for real time operation is something which comes from mechanical engineering background, because you're looking at robotics there. So this is something which 6G is really offering in the sense that if you want to do some kind of communication, you need to have those devices to communicate. So even if I look at e-health monitoring, for example, you're going to be having communication through, let's say, Wi-Fi or some tower, but you're going to communicate to a doctor who needs to understand what the messages are. So you're going to have an interdisciplinary or a multidisciplinary kind of an aspect. So this is something that 6G is offering, which is not offered by the previous generations, because there you only required communication or networking people.
Yes, in fact, you mentioned very clearly from the very beginning of the talk that is more on these 2 years. There are a lot of developments in this particular domain. There is huge changes happening. Yeah, so that is one of the reason being actually there are a lot of other disciplines are getting converged to get into this kind of projects. Yeah,
correct. Yeah. So I myself, if you see, I have in my group people who are from robotics background, biomedical background, who are coming, and so they do, for example, the biomedic part, right? But then when it comes to communicating that data, that is where my group comes in. So there has to be a handshake between what we say two departments, so to say. So that line between departments has become very less now. I think it's all. I think very soon we'll have only engineering. We'll not have departments.
Okay. Yes, in fact, data science getting picking up, like some of the other CSE branch specialization taking into wings. Like there is, in fact, inside the CSE department there is a lot of specialized areas are growing, and they are getting into the individual departments inside to that. So actually, I don't know about how things will work.
No, that is that in my opinion, it is a demarcation which we are making. But like I gave you the first example, deep learning for crack detection. You have a civil engineer coming with a computer. So I think that line is really getting washed away.
Previously we use finite element analysis for that, but for that is a one course application area where the crack and some of the failures of materials can be analyzed properly using those methods.
So just to give you an example, like I mentioned in one of the slides, we don't have modulators working at high frequency. So we have some materials people who are working a lot on those issues, and they have found out that graphene is one of the materials which can be used. So this is nothing to do with communication or networking. It is actually a material science person who would research on it and give us a solution. So this is a very good opportunity for everyone to come together and do a lot of research.
Yes. Thank you for that.
Yes, participants. Any queries?
Dr. Sridhar, we are trying to keep you as the first session of the FDP for the last few times, but this time we are successful in keeping your session. It's more lively. Even the participants, I'm getting the feedback now. It's a really wonderful session. Thank you very much, sir, Sridhar, sir.
Thank you.
And in between, we have troubled you because the participants have unmuted themselves.
No problem.
And this because we have a large gathering this time online. This will happen.
Yes. No, I understand. And thank you for having me. And it was good to interact.
Because we have today, this time we have international participants and also national participants from NIT Tiruchi. Also, we have 2 participants.
Okay, great, sir. Great.
Sunil, sir, please.
Yes, sir. Sridhar sir, thank you so much for joining with us. And really, you shared your valuable knowledge regarding how important is the 6G network, and you differentiated between 1G, 2G, because you started with a class that is what is retrospect of 1G, 2G, and then you started with 3G, 4G. How about the 21st century? And what are the requirements and how it is going to become in 6G, need of 6th generation, and cell-free communication in 6G generations and all. And mainly you focused on new resource and utilization methods of the spectrum, what we have in this. And mainly you added the capabilities, computing and integrated artificial intelligence, because you combined both artificial intelligence and resource allocation problems you came up with, which was very much useful for all the participants. As you already mentioned, it will be useful for both the scholars as well as the supervisors. Really, it is wonderful, sir, because you came up with some of the problems as well as the use cases with real-time examples, like how optical wireless communication is going to be held. And you worked with the integration of wireless informations and energy transfers. And finally, you came up with opportunities what we have in the research opportunities in the 6G network, sir. Really, it will be very much helpful for, as you already mentioned, for both the scholars as well as the supervisors. I strongly believe that this session is very much helpful for both all the participants as well as the supervisors and the scholars. From the Department of CSC, Sri Vishnu Engineering College for Women, once again, we thank you, sir. Despite of your busy schedule, you spend your valuable time for us. Thank you, sir.
Thank you. Thank you very much. Thank you for having me. Participants, you can contact me at all times. My contact details are with Kiran, sir. So I'm always open up for any collaboration. Thank you.
Thank you, sir.
Thank you very much, sir.
Thank you, sir. See you. Bye-bye.
See you, sir.